Hello everyone, welcome back to the part 4 of Convolution Neural Network series in Bytes of CSE, and today's topic is on pooling. Now when we apply deep learning to images, we actually try to get some information from that image, like if the image contains a dog or if some XYZ is present in the image and so on. So the final layer unit needs to be sensitive to the entire input. So what we do is we keep the advantages of convolution layers in the intermediate layers of processing. And as we move towards our final layer, we would start to aggregate the information, which means we will yield coarser and coarser maps, and we'll finally learn a global representation. So the deeper we go in the network, larger is going to be a receptive field with respect to the input for each hidden node. So we need to reduce the spatial resolution for each hidden node to be sensitive to a larger receptive field. And apart from that, convolution layer also has a disadvantage. Now look at these two pictures. These two pictures are essentially the same. There's a dog, the same dog sitting in the same posture in these two pictures in a white background. And these grid-like things I've just done to each of these actually represents a pixel. So the only difference between this image and this image is, see, at this image, if you consider this part, the dog is just 2 pixels away from this part, and here the dog is 3 pixels away from the start of the image. Now what we are trying to do, as I've said, we are trying to find the information from the image. So literally, when the same dog is present with the same background in these two images, we'll like the hidden representations to be identical, right? But this is not the case with convolution neural network. So I have actually done a supplementary video on vertical edge detection, and the video will be linked in the description box. If you have gone through the video, you would know that for this picture, when an edge detection kernel is applied on this picture, this black and white thing, this is going to be our hidden representation to show where the edges actually lie. Now just imagine the same picture, this white part, it just moves 1 pixel to the right. So this is going to be all black, and the image just shifts 1 pixel, So if it shifts 1 pixel, this is going to be the hidden representation. So the hidden representation, as you can see, also shifts 1 pixel to the right. Now you can't call these two matrices identical, can you? No. But this is the same image, same information and everything. So what pooling does is, pooling addresses this location or translation sensitivity of convolution neural network, apart from also spatially downsampling the representations. So what is actually pooling? In pooling, we have a fixed size window, just like our convolution, the kernel window that we had in convolution layer. And that window is slit over all the regions. So far it's almost like convolution. Then what's the difference? The difference is, here there is no kernel. So what are we actually doing with this sliding window then? For this sliding window, we'll be using some deterministic operator like maximum or average. Like for a particular window, we'll try to find out what is the pixel information, like the maximum pixel information or the maximum element in this window, or the average of all the elements present in the window, and so on. These are the two operators which are the most popular ones used in pooling. So let's see how does it work. So we'll be using a 2x2 pooling window, and we'll be applying maximum pooling, which is max pooling, which will find out the maximum of all the elements present in a particular pooling window. So we'll start just like a convolution layer. We'll start from this position for this particular pixel, and the maximum of all these elements is 8. So 8 comes here. Now we'll shift the window 1 position to the right, and this is going to be our our pooling layer, and the maximum of all these elements is 5. So 5 comes here corresponding to this pixel position. Again we'll shift to this position. This is going to be your convolution window, and the maximum of these is 4. And finally we'll move one position again to this part, and this is going to be your information for this pixel. And now we'll move down. Moving down, this is going to be your convolution window, and the maximum is 9, and so on. It slides just like the convolution, the kernel window slides. This pooling window also slides a similar way, and this is going to be your final output. So the dimensions of your output, or the shape of your output representation, will be same as that was shown in the convolution layer, which I had shown in part 2 of this series. So I would request you to go back and see that, watch that again if you are not aware of it. I'm not going to repeat those parts here. And just like your convolution, padding and stride can also be applied with pooling. And now we'll take an example with padding and stride. Suppose this is your input image. We'll be taking or considering a pooling window of 3 cross 3 in this case. And a padding of 1 cross 1 will be applied, one on top and one on the leftmost side. And a stride of 2 will be considered for this. So let's apply the padding. And now after adding padding at this position and this position, it looks like this, the image looks like this. And we'll start with the pooling now. So it's a 3 cross 3 window. So similarly, we'll start from the topmost left corner, and this is going to be your first window. And we are going to use max pooling because see, these you won't actually have to calculate. There will be layers, like pooling layers are present in all the standard libraries. So this is basically the BTS that is going on, that I'm showing you in this video. So I'm using the max pooling just for ease of calculation, or whatever you call it, computation. So in this case, this is going to be your maximum, that is 8, and this 8 will be for this position. And now for any stride k, when we start from this position, we will either move k positions to the right for stride k positions to the right, or k positions down. When we are done with one whole row, we'll be moving down, right? So here the k is 2, so we'll move 2 positions to the right. That is, the window moves 2 positions to the right, which means position 1 and position 2. So this is going to be your next pooling window, a 3 cross 3, and this is going to be the maximum in that pooling window. Now again, we'll need to move 2 positions to the right. So we are here. This is the start of the window. We are to move 2 positions to the right, 1 and 2. But the problem is there aren't enough pixels to cover the entire pooling window. So we are going to move down. We are not going to move any further. We are going to move down. So starting from this position, we'll need to take a stride of 2. That is, we'll need to shift the window to 2 positions down, which means the window is now this one. This is your window, right? And the maximum of that is 9. This is the window, okay? And now again, we'll take 2 positions stride. That is, we'll shift 2 positions to the right, which means this is going to be your next window, and the maximum is 7. And your final output is going to look like this. And now let's see how it works. Pooling works with multiple channels. So one of these, like this one, is the same as the previous, the one which I have shown, like this one. This is same as this, and this is going to be just one element, like this plus 1 is going to be this channel information that is shown in this like in this matrix. So here we are going to take the similar 1 cross 1 padding and a 3 cross 3 pooling window with a stride of 2. So in case of your convolution, when we were dealing with multiple channels, what happened is each position, like each kernel will be applied to the corresponding channel, and the scalar output for each window, like if this was x and this was y, those x and y's were added together to get the final output information for that particular pixel. But that does not happen in pooling. Instead, we are separately going to add the pooling window, and whatever be the output, that is going to be the output for that particular channel. So for this particular channel, this was same as that was shown in the previous slide. So this was the output. So this is the output corresponding to this channel, and then we will be using another convolution, sorry, a pooling window for this channel, channel number 2. And similar to this channel, this is going to be the first pooling window where the maximum is 9. Then we'll shift 2 positions to the right. This is the second one where the maximum element is 6, this one. Then we'll move down 2 positions, that is, this is going to be our element in consideration, and the maximum is this one, that is 10. And again shifting 2 positions to the right. So this is going to be the final pooling window for this channel, and the maximum would be 8. So this is going to be your final output for this channel, and these don't interact with each other. So this is all about the basics of pooling that you would need to know, and I will be coming up with supplementary videos on convolution neural network, which I would not like to merge with the original tutorial. So tutorial is only for the basics of convolution neural network, so just keep an eye for that. And that's all for today, and thank you for watching.